Okay, 15 and 16, guys. Solve each equation for n. State any restrictions on n. So what we need to refer back to is our permutation formula. Yeah?
Will the notes be on, will the notes be on the website?
All the videos are on the website. So yeah, for your notes, yeah. Like
I think I missed it.
Okay, if you missed the lesson, yeah, go on to mrmathwell.com and look up your 4.3 lesson, which should be right here. 4.3 is right here, permutations, distinguishable objects right there. So you want to watch that, and I'll be putting some of these homework questions on there too. All right? All right, so the permutation formula, let's back up for the permutation formula. That's what we learned the other day. And that's going to be way back. Well, it was there, I guess, but here we go. So this one right here. So if we have a total number of n objects and we pick, remember the P stands for permutation, but it's a good thing to think about pick. You're actually picking things, like purposefully picking things. So that's kind of like making an arrangement. If you have n total number of items and then you pick r of them at a time, how many different ways could you arrange that? And so it looks like this. This is the formula. So I'll just grab that and bring it back down to the question. So you're going to want to fill in what values you can. So here for this one, np2 equals 20. So we actually did this one the other day. So I'll just show you the working of this one. The permutation formula, okay, looks like this over on the right. So n is just n, and r is 2. So the bottom looks like n minus 2 factorial. So we go ahead and simplify the left side of our equation, just like we did in previous sections. And I would write the actual factorial, or a portion of the product of that factorial represents, until I got the same factor on top, or factors on top and the bottom, and I would be able to cancel those out. So you simplify the left side as much as you can. When you're done simplifying, you see that you have these two things multiplied together, and when we multiply those together, you get n squared minus n equals 20. Don't forget about this on this side. And that turns into a quadratic when you get all the terms over to the left side. You have a number of different ways that you can factor a quadratic. You need to know how to do that. So you either do that by sight, by intuition, or there's the quadratic formula. There's factoring by decomposition. So we've gone over those, and you've learned those in previous math classes. But what you would find out is that the two possible solutions now for this equation are n equals 5 and n equals negative 4. And we reject the negative 4 because we can't have a negative number and take the factorial of it. Okay, so that's 15a. So the answer would be 5, and you check that. 5 pick 2 does equal 20. Okay. Fundamental counting principle, I suppose if you thought about it that way, if we had 5 options for the first choice, if we're picking 2 at a time, we have 5 options here, and then we have 4 options for the second one. So guess what? That's 20. Okay, that's a really easy way to think about that too. So fundamental counting principle for simple problems would work as well. 15b, this is the question for 15b right here. You have n plus 1 pick 2 equals 72. So simplifying this side is going to require us, again, to know what that formula is. Let me just shrink that down a bit. So there's the formula, and so I want to plug values in. So the n is actually n plus 1 here in this question. So I'm going to put that in where you see n, right? I'm going to put n plus 1 there. And on the bottom, I need to have n minus r, or n plus 1 minus 2. And so when we go ahead and simplify that, and I'll let you do most of this. I'm going to let you do most of this, but I'll just kind of get you going one more step from here. So when you simplify that, the first step would be to do this. And then what's plus 1 minus 2? That's going to be n minus 1. Yeah, that's right. So you have this, and then now you can go ahead and simplify just like we did in 15a. So n plus 1, I guess I'll do one more step for you. N plus 1. You subtract 1 from there, it gives you n. Subtract 1 from there gives you n minus 1 factorial. So now you have n minus 1 factorial on top and bottom. Equals 72. Those are gone, blah, blah, blah. Same as now 15a. Okay, so that's 15. I had questions about 15 and 16. You guys think you can carry on 15b now to the end, just like 15a now? Okay. All right. Okay, I'm going to go ahead and look at 16. So 16 down here, solve each equation for r. Now, solving for r might get a little bit tricky. You might have to do some guess and check, but you have an idea of what you're looking for. So let's see. 6 pick r equals 30. So in using the formula, I'm going to go 6 factorial up top, and then I'm going to go 6 minus, well, I don't know what r is. Okay. Factorial equals 30. Okay. So let's see. This is a bit of a tricky one because 6 factorial, how do you simplify this, right? So 6 factorial over 6 minus r, yeah, equals 30. Okay. So if you go ahead and break 6 down, that's a little tough. Like how do you get r in the top? So what we can do is we could figure out what this whole thing must equal, right? Because I can't really isolate for r. I can't really break it down or simplify it too much. So if I multiply both sides by 6 minus r factorial, and then divide both sides by 30, I could get at least this quantity right here by itself. So this is the way I would probably tackle this. So 6 factorial divided by 30 should equal 6 minus r factorial. Okay. Now you're thinking, well, how does that help? That doesn't really, well, it gets the r, at least in the numerator, on one side. And I could actually figure out what this is, couldn't I? I could actually figure out what that is. So I'm going to try to do it without a calculator. 6 times 5 times 4 times 3 times 2 times 1 over 30 could be represented as 6 times 5. So guess what? I have this. I have 4 times 3 times 2 times 1, which is actually 4 factorial, isn't it? Equals 6 minus something factorial. Now your eyes should be lighting up and you should be going, oh, hey, if I have an equation, the corresponding parts of an equation would have to be equal. And the corresponding parts would be like this 4 factorial has to equal 6 minus r factorial, or 4 must equal 6 minus r. Do you see that? So r, in order for this to be equal, r has to be 2. Right. So just carrying that on one step further, you would see that 4 must equal then 6 minus r, and r is 2. Okay? So that's kind of using a formula that you know, using some math manipulation that you've learned before, and using just your intuition there by noticing corresponding parts to equal things must also be equal. Very good. Okay. B, I'll get you started on B. I won't necessarily do the whole thing for you, but B, probably a good idea to divide both sides by 2 first. So get rid of this 2 over here and make 7PR equal 210. That's what I would suggest. Okay? So I'll tell you what, I'll give you a few minutes. If you haven't done 16B yet, do that please right now for a couple minutes or a minute or two, and then I'll check back in with you and see how you're doing with that, okay? I'll make a little space here, and if you need some further clarification, I'll help you in a couple minutes. But everybody, give that a good try if you haven't tried that yet. All right, so there's your answer for B. So very similar to what we did before, I mentioned that you should divide both sides by 2 first to get 210. And if you fill in the permutation formula, you got 7 factorial divided by 7 minus r factorial. Now that r is kind of caught inside that factorial. You can't really pull it out there. So let's try and get this quantity by itself. So multiply both sides and then divide both sides by 210. And you get something like this. When you simplify 7 factorial over 210, you should get 24. Am I frozen? Sorry. You should get 24. When you get 24, now the tricky part is finding out if 24 can be represented as a factorial. And of course, it probably wouldn't take you too long to figure out that, yeah, it's 4 factorial. You could check 2 factorial now, 3 factorial now, 4 factorial. Oh, yes. So it shouldn't take you too long to figure out if this is an actual factorial. So this is actually 4 factorial. And so 4 must equal 7 minus r, r being then 3. Good? Yeah? Does that help?
Wait, how'd you get the 24?
The 24, 7 factorial divided by 210. I might have that on my calculator still here. I don't know. Oh, no, I didn't do it on this calculator. You did what?
I did it without using the 24. So I expanded the 7, and then I saw that 7 times 6 times 5.
Sure.
equaled
Equals 210?
Yeah.
Yeah, sure,
And then
sure.
stood down as
So
well.
yeah, you could do this. This was 5 times 4, factorial over 210 is 7 times 6 times 5, you said?
Yeah.
Yeah, right. So there you go. You could do it that way too, and those cancel out. You're left with 4 factorial. Yeah,
Okay. So
totally
either
could do
way's
that.
fine.
Yeah, and you could just do this on your calculator. This one works on the calculator, but yeah, that's great.
Okay.
Perfect, yeah. If you had like a large number, like, 217 or something factorial, you probably wouldn't be able to do that on your calculator like I did, but that would be a great way to go. Yeah.
Why didn't you use factorial instead of just using the actual?
Why do I use factorial instead of just using the number down here, you mean? Like it sort of turning the 24 into 4 factorial? Is that what you're wondering? Okay, so the reason why we do that is because and I'll highlight this, on the right side, you have a factorial right here. See that? So you have 7 minus r factorial. So in order to solve for r, I need to try and change this into a factorial expression as well. So now 24 is 4 factorial. This factorial part is now the same on both sides. So now I can focus on the 4 and the 7 minus r only. Does that make sense? Okay. Like, it's kind of like if you have x divided by 20 equals 4 divided by 20, you know that the x has to equal 4 because they're corresponding parts of equal things. So that's kind of thing. All right, excellent. Good job. These tough questions.